Try my recording one more time. So there's what we did with the driver. We had this idea that we had a phone that people basically gave their name and they got a phone number, and that's how the phone ended up being registered. And you could talk on your phone for a while, and that would just make the number of minutes that you talked go up. And then we said, well, okay, but you could also have a cell phone, which is really a kind of phone that's got some extra, some planned minutes that you buy for the thing. And then when you exceed that number, you can still talk on your phone, but when you exceed that number of planned minutes, you pay more. So it's a special kind of phone where you basically pay more if you talk more than what you've paid for. And then there's the prepaid phone, which is some kind of phone that you can also register with a name and you get a phone number. But for a prepaid phone, you always end up having to buy minutes. And so there's this idea that after you've got your phone, you turn around and you buy some number of minutes, whatever it happens to be, 200 minutes, and now you've got the equivalent of a cell phone, but it's only good for 200 minutes. Okay? But they're all types of phones. And so we started out and wrote the phone class and said, well, a phone class has got, name and number and the amount of time that you've talked. And we wrote basically a complete phone class as the starting point for a standard phone. And then when the special type of phone came along, we just said, oh, well, we already know what a phone is. Let's just add some more to it. So a cell phone is a special type of phone that just happens to have planned minutes associated with it, in addition to all of the other stuff that we already know about the phone. And so the extends word there really means adds to. And it actually would have made more sense if they would have written adds to. Right? So there's another sort of not necessarily the best choice of words, but the standard is extends. Okay? So cell phone adds to existing phone class by adding some variables and also some extra methods. And so these methods here for plan minutes deal specifically with that variable. Okay? But there's already some existing stuff in the phone class that needs to be initialized, and so we call the constructor for the phone class to do the initialization, and the word there is super, which really means phone. Okay, so that's the phone constructor that's being called to initialize the variables that are specific to the phone underneath, and then we'll take care of initializing any extra stuff that we've declared afterwards. Okay, and there's the getters and setters for the extra stuff. But in addition, we have this sneakiness of you can also turn around and you can also override existing behaviors. So the phone class already has a toString in it. But the problem with the phone class's toString is that when we add extra stuff, the phone class's toString, the default one, isn't going to print that. And so what we do for cell phone is we override the existing behavior of the stuff that we inherited, which is the toString from the phone class, and we're going to go grab whatever it was going to say anyway, and then we're going to tack on our additional information to the toString. And so now when you call the toString for the cell phone class, you actually get all the stuff that phone said plus a little more that reflects our stuff. And so there's our idea that we're building upon existing stuff by either adding our own or modifying the behaviors of the existing stuff to get it right. Okay. And then after that, we went and we said, well, okay, prepaid phone just happens to be a special type of cell phone that starts out with 0 minutes, and then you buy minutes afterwards. And so we had this sense of, oh, okay, you can now turn around and buy some minutes to the thing, add to the minutes that are already there. Now, the problem with adding to was that it was a lot of work, because we were calling the getters and setters from the previous classes in order to do the work of getting and setting the minutes, getting them, changing the value, putting it back. Okay? So the shortcut to doing that was to say, well, what we can do instead is that we can go into these other classes, in particular the cell phone class, and we can mark the variable as being protected, and protected means anybody who extends still gets the privilege of using that variable because they sort of belong to the same family anyway. Okay? And so in that case, we can shorten the work to saying we'll just do this and have access to the variable directly in the class up above us. That's okay, it makes life shorter. The problem with it is that if you put protected on the thing, now people can change that variable at will without going through the getters and setters. The idea here is that, well, if you're a member of the family, you're probably doing the right thing with it because you know how the family operates. If you want to be super safe, what you'll do instead is not mark things as protected if you can get away with it, and say, no, you still have to access it just like anybody else would, because that gives me a chance to control the variable with the setter and make sure you're following the rules I expect you to follow. The other thing we said about inheritance is it only works so long as you don't start to squirm too much. And so, it's as with other things, if you're inheriting from the family and you're supposed to be a doctor and that makes you squirm, right? Eventually you decide to just go your own way and say, I'm a totally unique person, not like part of my family. Okay, and that's the way I want you to treat me. So sometimes if your behaviors are going to be totally different or are too much from the norm that you've established from this class that you inherited from, you just say, oh, forget it, let me start fresh, do all of the stuff that I want to do in the way I want to do it, and you essentially break away from the family. And there's no right or wrong about when you do that. It's really just how much trouble am I having to go to in order to fit in.
Can you have two children from the same parent? So say you decided that instead of saying extend cell phone, you could say extends phone.
Yeah, you can extend whatever class you want, because remember, extends is just add to. So you can add to any class.
Yeah, extended cell phone, because we're like, what cell phone already had for the prepaid phone, right?
You only get the stuff, you don't get the stuff from, you get the stuff from the parent, not from the intermediary.
Okay.
So you can't, because you don't know about that. So you can only extend one class, not both. Okay. Some languages, like for instance C++, allow you to actually add to more than one thing, and that sort of works, but it gets really ugly when the things that you're trying to add to both end up having the same methods in them that behave differently. Right? And so Java, rather than do any of that stuff, says that you can only extend one thing. You have to have a direct lineage with just one thing and not multiple things, because that just makes things really weird. Okay.
Only single parent families allowed?
Yeah, essentially. Okay. So that's the sort of the review of that thing. I'll just point out a couple of things here. It turns out that on the phone class, when we write it, even though you write it like this, it actually, the compiler ends up putting that stuff in for you to say extends object. Okay, that big O object. And that actually explains why when in the driver programs, whenever we've gone and we've used the IDE and we've just made this basic phone class, and then we do my phone dot, it's like, well, hold it, I didn't write all these methods. Where did they come from? Well, they came from the fact that you extended object. So we wrote get name, number, and talk time, but there's already an equals method, there's already a toString method, and some others in this class that we don't know about. Okay, so now you understand why, for instance, toString, if you just use one of these classes that we've created in a toString, it prints out the memory address. It's because the default behavior of printing out the memory address is already an object, and all that we're doing when we write our toString is we're overriding or hiding a behavior to modify it to make it different, which is now we're going to print out the information that we really know about this object. Okay? So that's one of them. The other one that you see is that there's always a default equals in object, and the default equals method is identical. Okay, so by default you get double equals for that thing, and when we write our own equals, we're changing the behavior of the existing one, which is why that method signature has to be exactly correct, and it has to say object there, because you're trying to override the one that's in the object class with one of your own. So it has to look like that. Just out of interest's sake, why is there no compare to in object?
We haven't done a compare to yet.
Compared to.
But why isn't there a default one in,
Compared to is used with lists and objects, not lists.
but you could write one, we always write one for the single things that we do, and object is really a single thing, right? They obviously wrote an equals method to say single
Is
thing.
it new?
Well, yeah, there's sort of nothing to compare, about the only thing that's left is like toString prints out the memory addresses, so you could sort things based on memory address, but that sort of doesn't make sense. So they left it out because there's no reason to put one in, which is why for compare to, you notice that we say implements comparable to say that we want to now add a behavior that wasn't there to begin with, right? So we're not extending, we're not overriding anything, we're adding something fresh and new. So it's just no reason to write a compare to, basically. So extends is a little, or implements comparable is a little different in that case. Okay, and I created an error in here someplace, which I'm sort of not going to worry about. I think that's because my disk filled up earlier, but we're sort of done with this class anyway. Okay, questions about inheritance? Let's try one more example. We've been using lists, and one of the things that we've discovered with lists is that they're always zero-based. And there are times when human beings want a one-based list, so first, second, third is an example of stuff that we've been working with. Wouldn't it be nice if there was a list that started at 1 rather than 0? Okay. Well, we could go in and we could start writing a class for a one-based list. Instead of a zero-based one. What ways could you do it? Well, the first way is you could put an array underneath it. So there's the square bracket array stuff in Java too, but the problem with those square bracket arrays is that you have to specify a size, and then if you run out of room, you got to do all sorts of work, and that's what array list is doing for us. Okay, so it sort of makes more sense to use array list. So what we've done in the past is we've said, oh, okay, we'll make a list of all things, whatever it happens to be. I'm going to get into a little bit of trouble here with some weird errors because I'm not using the angle bracket notation here. So we'll just hopefully just give you the right idea. We could write private list, you know, all things. We could import list. We could write our constructor to initialize it, which I'm not going to bother. And then we could start saying, oh, okay, well, if you do an add to a one-base list, I'll just write an object here for one of anything else. You could turn around with this one-base list and just call all things dot add that item to get it in, and then when somebody asks for it, by position, what we'll do is when they say 1, we'll just say, oh, they really mean 1 less than that, they mean 0. So position minus minus, and then we'll send back all things dot get the thing at that position. Okay, which is sort of what we've been doing so far. We've been adding a list into a class we already own, and then we've been saying, okay, we'll just modify the behaviors by, when you say add, oh, I'll just call lists add, and when you say get, I'll just call lists get or lists iterator. The only thing I'm doing different here is I'm modifying what they tell me a little bit so that now it looks like a one-base list. Okay? That's the way we would have done it in the past, but now there's an easier way. Okay? The easier way is to say I'm not going to bother with all of this stuff. What I'm going to do instead is I'm just going to say my one-base list extends array list. And do the import statement, and don't worry about the yellow bulbs, okay? So notice I haven't written anything in my one-base list class, but if I go and write a driver, and put that in the wrong place. I'm just going to slide that back into the default package. And because my default package has got fish in it, so I can do something like this. I can make a one-base list. There's my new one-base list. Then I can do a list dot. Oh, look, as soon as I extend list, I get all of that functionality that the list has. So I'll do a list dot add new fish, just to put something onto the list. Okay. So notice that add works already. I can then say fish, a fish is a list dot get, and in this case, I really want that thing to be the first fish I've added onto the list. Okay. Well, if it's going to be the first fish, then now I can override the get by saying public object get position, do position minus minus, and then return super.get, just to be clear. Return the regular lists version. And that's really all I have to do to get a list that now operates using 1, 1, 2, 3 rather than 0, 1, 2. Done. And just for fun, we'll go around. There's a little, I think I probably have to do this just because it doesn't know. There we go. And then if we put a breakpoint in here and just go see it in action, run with the debugger, do a couple of step overs, and go look at the fish we get back. Now all of a sudden we've got a one-based list that returns our carp. Okay, was all there was to it. So there's an example of using inheritance to modify the behavior of something that's already around to suit your purposes. Anything else we need to do? The subtle thing here is that get and add work, but you also inherited a bunch of other behaviors. And if we just go and type a list again, we didn't just get add and get, but we got the full meal deal on all of these things. And the question is there anything else that cares about positions in this thing, because we now want our positions to be 1-based rather than 0-based? And well, yes, there is that thing that says index. There is another word for position. I don't know what add does, or that one does, but we'll go down to one that you do know. You can remove by position. And now all of a sudden we have to correct the behavior of remove, because chances are pretty good somebody's going to want to remove things from this list also, and they're going to want it 1-based. Okay? And that's what I meant about that burden of inheritance forces you to now do some other things that you might not have wanted to do by virtue of the fact that you just acquired those things and you need to change their behaviors. So if we now have to change the behavior of remove in order to make it work properly. So let's just do that. So we'll go into 1-based list and we'll say, okay, I guess we have to write a public void remove by position also. And if you remove something by position, we still have to decrease basically any of those position numbers. And then we can return super dot remove by that position. Now remove actually returns the object that was removed, just in case you want to know what it is. So that's what the actual signature looks like. Okay, so now I've done 2 of the however many I have to do, and I'm starting to get tired. Okay, well, maybe this just represents the only things that I want people to use, just, add, remove, and get. Is there any way I can restrict them to just using add, remove, and get? Of course there is. You just know there's, I wouldn't have asked that, right? So there's got to be a way. What do you know that restricts people to only using standard things? An interface. So if we made an interface that only said these are the standard things that you can use, and people said, I'm going to make a variable that represents the interface, then we would restrict them. Okay, well, let's do that. It turns out that Eclipse has a facility that's sort of easy for doing that. I've been using it. Now you can find out. There's one called extract interface. And extract interface will take the existing class and basically do all of the work for you of saying, oh, there's get and remove are the things, the methods that are in this class, and there's a bunch of crud here I just don't want, so I'm going to get rid of that. And I'm going to call this thing 1-based list interface. And I'm going to let it generate my interface file, wherever it is, if I can see it here, that one. Okay, and it also has, by the way, it only got the ones that were in that class, but there's also public void add something. So I need add, otherwise I can't put things on the list, which would be sort of nice. Okay, so now what I've done is I've said that thing is there, and that thing extends 1-based, and oh, I guess I got my add slightly wrong, which is what it's complaining about there. Return types, what does ArrayList add return? Let's just go find out here. Returns a Boolean to say whether or not it was added, which is fine. So we'll just go to the interface and we'll make that interface, wherever it went, be correct and return a Boolean in accordance with what add actually does. Okay? And so now, since that thing says you can only do add, get, and remove, I can go into my driver and I can change the word on the left-hand side there to do the restriction. And now that basically says I'm restricting that variable A list to only using add, get, and remove, which are the only things that we overrode anyway. And now this thing will only do the 3 things that we want it to do from the list class. And we got the restriction back again. Okay? So there's the power of that inheritance, is that with really very little code, I managed to change the behavior of an existing thing and restrict it to do only what I wanted fairly easily, and didn't have to go through and write a whole lot of code, just borrowed code from other people. Which is particularly good because all of that other code has been tested, and I don't really have to test much of anything in order to see whether or not this works. I'm not writing a whole big, huge class from start. Okay? So there's the second example of doing that. And that's it for inheritance. Go back and see what's next on my list. Okay, one more little trick here. Let's suppose I'm trying to come up with an assignment for you people to do, and we'll go back a few weeks. I'm trying to get you to work with lists of things like we've been doing. So let's see if I can come up with an assignment. I want you to make a class that does a warehouse. Okay, so here's Darryl starting going, well, okay, they're going to have to do a warehouse. What are they going to need to put into the warehouse as well? I'll make them put boxes into the warehouse. And without writing too much a box, I already know that this should be private. If I were doing the solution, I would say it should be a list of boxes, all boxes, and I guess I need a public void add a box, and I guess I want them to write, I'll have to figure out how to do that at some point. I'll write public box get position to see if they know how to use a list to retrieve something. So I'll write that stuff. I guess I should do the import statement here. Let's see, maybe the thing will have a name on it. Name, so I'll have to write a constructor, public warehouse. And oh, I know how to initialize that. That's all boxes. They always forget that, so I'll do it for them. An array list that can only contain boxes. Did I do that right? Oh, missing a bracket. Do the import statement. I'm getting sort of lazy here. I guess I'll do the name. Seems like a lot of work. I'd rather go have a drink or something. So I guess maybe they should write the rest. Okay, I sort of got it half started. Time to leave. Here's a little trick. I'm going to do what I did for interfaces. And I'm going to say, oh, I think that's something you should write. But this time, I'm going to put the word abstract on the front of it. Oops. And I'm going to put the word abstract on the front of this thing. And abstract really means I was too lazy to write it. And then I'm going to say, oh, okay, well, I was actually really too lazy to write the whole class, so I'm going to put abstract on the top of there. And, oh, look what happened. All of a sudden, all of the syntax errors are gone, and it's saying, oh, that's acceptable. But the word abstract here means incomplete. I did a half a job and I got tired and I wrote what I thought was, I picked off the easy stuff and I said, oh, okay, now I'll leave the hard stuff for you people to go write. I knew that everybody at least should write this much. Okay? So, how does that differ from an interface? Just out of interest's sake.
Well, the interface restricts, whereas this basically removes all restrictions.
Well, the restrictions are still there, right? I mean, this part is still interface, right? Because I still listed out all of the methods that I thought were going to be important that somebody's going to have to write. The difference is that now I can give you some hints about the kinds of variables that you're going to have to use, and I can write some of the code for you. Okay, and I can pick and choose, what code I think is easiest or that everybody's going to have to do, and I can do all that for you and then leave a whole bunch of undone stuff. Okay? And so with that undone stuff, what you can do now is I can give that as an assignment and I can say everybody needs to go make this work. Well, in order to make it work, what you do is you start out and you write your version of the warehouse class. And now, what you do for the assignment to start it out is instead of saying implements like you would have done for an interface, you say extends the existing warehouse class. Okay, and there's going to be a couple of complaints here. It's going to say, oh, you didn't actually do that stuff, so we'll just add the unimplemented methods, and there's the unimplemented methods that you need to write. And also it's going to say, it's going to be nice, and it's going to say, oh, you need a constructor. Let me add the constructor in. And look what it did for the constructor. It was smart enough to go, oh, the other constructor required a string with a name, so let me plop in a string and call the superclasses constructor to even initialize that for you. And now all you have to do is just write these methods to do what you want to do in there, just like you did with interface. But now you know that in this case, because this class has already got those variables there, you can now make use of those variables, particularly if I mark them as, I should have actually marked this as protected, just so that you can get at them. So I'll mark that one as protected to say there's a variable you might have to change. And now in the warehouse class, you can now do all boxes dot add the box, because you have access to that all boxes variable from the abstract class. And the same thing there, you can just return all boxes dot get the thing by position in order to make that one work. Okay, so notice that now we've got the full range. We started out at the beginning of the term going, I have to describe everything in English to you, and you have to read the English words in order to try and make sense of what do I mean for method names and what sort of stuff is going to be added. And then we said, oh, well, that's not too exact. How about if I give you an interface where at least I've described the names of the methods that you can use and all of the information that goes in and out. That'll make it easier so that everybody sort of writes the same thing and uses the same words. The abstract class goes one step further and says, well, not only can I give you the names of the methods, but I can give you the names of the variables. I can write a bunch of the stuff for you to get you on the right track, and then I can leave some unfinished stuff for you to go on and do yourself, which means we can still have competing versions of the same thing, but we're all started with essentially some of the same amount of code, and we're just adding to. Okay, so, or as a convenience, you know, if we're doing a lot of this stuff, oh, okay, here's the stuff that we know you're gonna need, and now everybody can just go work from there. Okay, and so an abstract class is an unfinished thing that's got almost, you know, some portion of the stuff done, and you always have to finish it off in order to use it. So you can't go make a new version of this thing. You can't make a new abstract object like a new warehouse because it's not complete. It just won't work. Okay? So things that are marked are abstract, by definition incomplete, but they do have some useful stuff in them to help you along your way. Okay? So they're beautiful little things. There are, we talked about this already, I guess. There are some ways of extending more than one thing in some other, in C++, for instance, but Java doesn't allow you to do that. You can only extend one thing. You can implement other things afterwards. And an abstract class, by the way, is also like the sense of doing an interface. You can always add extra stuff to an abstract class. The abstract portion, like an interface, only defines the minimum that you have to write. You can still write more stuff on top of that if you want. Okay, questions about abstract classes? You can just bet on the next assignment I'm gonna have you write some, or work with the abstract classes, because they're an easy way to get you all to write the same thing. Okay. And I think that just about covers all the stuff we need to do for today. So enjoy your extra exam study time.